From everybody here, I'm curious who had heard about Hop Latent Viroid and cannabis before seeing the program. If you can raise your hand. 1, 2, okay. Not bad, actually. Sometimes when we talk about this in the United States, it's much less than the amount of people here. To briefly introduce where I'm coming from. So I'm from Purple City Labs, and we're basically the R&D division of Purple City Genetics. We aren't really a company geared towards producing products and putting it on market. What we do is we support breeding programs that happen in our nursery as we're making seeds, coming up with new cultivars to make cuttings to offer to people. So we do, a lot of pollen analysis. We develop molecular markers to help with our breeding programs. So this is mostly what we do. This story that I'm going to tell you has actually kind of ended up in a product, which is interesting. So when we find things that we feel that other people can also benefit from, we do commercialize it. There's a little bit of a backstory to this whole thing. 10, 15 years ago, mostly on the West Coast, people started noticing these weird-looking plants, and they started calling them duds, colloquially. En castellano puede ser un fallo. No sé cómo traducir mejor. So there's a lot of, cannabis forums. This is kind of where most of the discussion was happening, people trying to figure out what it was, different theories. Some people, there's this idea about genetic drift, which people use mistakenly as kind of deterioration of clones, when actually scientifically it means a change in allele percentages within a population. But people observe, and I think Rob, you called this the photocopy effect. So when you make a cutting over and over again, the cuttings start losing vigor. So people thought it had to do with that. Some people thought it might be nutrient deficiencies. People thought it could be tobacco mosaic virus. There are all these theories about what was going on. And then there was, of course, a lot of information about how it was spreading in different nurseries. And then some people started to really take it seriously, do some work in tracking it. One person I think that deserves credit is Rick Crum from Humboldt DNA, and they named it a putative cannabis infectious agent. So we should talk about the symptoms, right? One thing that is really important is that it's, there's kind of 2 different stages of the symptoms that present themselves, which follow the 2 different stages of the cannabis plant in its vegetative stage and its flowering stage. So in these pictures, what you're seeing on the left, those are healthy plants, and the ones on the right are plants that were showing these symptoms. These are the same cultivars, grown underneath the same conditions, the same age, everything except one of them is displaying symptoms and the other one isn't. So what people were observing were a lot of stunted growth, really, really brittle stems, sometimes so brittle that they would just break off by themselves. This like outward growth. These plants, although I haven't taken a closer look, they look pretty healthy. But they would kind of branch out, smaller leaves, overlapping blades, sometimes chlorosis of the leaves. But then once it went to flower, then it becomes really apparent what's going on. Huge amount of reduction of trichomes, no terpenes, really dull smell. And it's a big problem if you're producing for cannabinoids. And then people figured out what it was. So 2 different groups independently did the scientific work, which involves RNA sequencing. I was involved in one of the groups, actually both of them in a different capacity, but it's a longer story. And then the other group actually proved Koch's postulates, which is when you show that what you hypothesize is causing a particular symptomatic state, you infect healthy plants, and then you recreate the disease. So it was pretty conclusive evidence that the infectious agent causing these symptoms was Hop Latent Viroid. So let's talk about what that is. So it's not a virus, and COVID is, I'm sorry, it's like we're talking about another virus, and all of this kind of really the cannabis community became aware right during the pandemic. So it was this like double crisis that people were living through, You're dealing with one virus, here's another viroid, and there's some interesting parallels actually. So I apologize, I'm gonna make those COVID analogies. So it's a circular RNA. It was discovered by Czech scientists. A lot of the work around Hop Latent Viroid was done at the Hop Research Institute in the Czech Republic. You can see this image is actually the sequence with the secondary structure of the viroid, which is in 1988. They published this. But in hops, you can kind of manage it. You can there's some reduction of alpha acids. There's like a shift in the terpene profile. Interestingly, in hops, they see the terpenes shift towards myrcene, which, if you're breeding away from myrcene, which I think is a breeding goal for some people, that could be a problem, right? If we're seeing the same thing in cannabis. So this is one of the first COVID parallels. It's latent, which means there's a lot of asymptomatic transmission. So it can spread without displaying symptoms, and then you only realize it kind of once it's too late. The primary mode of its transmission is mechanical, so tools, wounded plants, handling the plants in the nursery, that's its primary way. And it's really bad for cannabis, much worse than hops. There's people trying to figure out what the effect of it is in the cannabis cultivation on the West Coast. But when you look at your facility where you're producing the plants, 30% loss of yield, terpenes gone, and people think that, definitely the majority of the nurseries in California, Oregon, Washington have this, and some of them have 30% of infection rates. So it spreads really easily. So some of the things that you can do for this, the most important thing, it's like your first line of defense, is that you need to have your nurseries in really good shape, right? So you need to have your tools being disinfected between cuts, between plants. This is the best thing you can do anyways, but for this particular problem, it is 10% bleach. You should use that. There's some commercial products out there that you can also buy, which are, less corrosive on your tools. You can heat them if you want. Changing gloves, disinfecting gloves. You need to have an organized nursery, right? So when something new comes in, it has its own spot. If you want, you can call it quarantine. And you track your cuts to the plants that they came from, so you can kind of know how things are moving around and just having a generally organized operation. And you need to have a really good staff. Okay, so that's the first line of defense. It's kind of like wearing a mask. And then testing. So this is kind of the main part of my presentation. The only way to test for Hop Latent Viroid is through molecular biology methods. You have to test for the RNA. It doesn't have this capsid structure with spike proteins like we know in SARS-CoV-2. So it's just naked RNA. There are no kind of rapid tests. You have to do some kind of molecular biology reaction to be able to detect it. So first you make DNA from the RNA, and then usually, we all probably know what PCR is by now. We might have all had one at some point in the past 2 years. It's followed by PCR, But then even more than that, because it's latent, which means that it's not necessarily replicating all the time. You need to test relatively frequently, over and over again, to kind of make sure that it hasn't spread around. And you need to have a good sampling program, right? You can't just take one sample from one part of the plant, test it, get a result, and that's it. You need to have a comprehensive sampling situation of your plants. You need quick turnaround times, so that you're not waiting for weeks while maybe it's spreading. And then so you need this like high throughput, large scale testing, of course, depending on, our nursery is relatively large, but if you have this many plants, then you don't. But I'm talking for like commercial operation. So let's talk a little bit about the testing. I'm going to kind of compare two different methods. So PCR, invented in 1985, every molecular biologist does it almost every day. It's kind of like central to everything we do. It's very sensitive. People call it the gold standard. And it's a chain reaction, so you're cycling between different temperatures, and that's how you amplify your target, right? So all these things work through amplification, which is basically making something invisible visible. And it does it by going between different temperatures really rapidly. Usually it takes 3 to 4 hours from sample to result. But if you're doing a big scale, you need an infrastructure, you need a lab, you need fancier machines. So it kind of is drives towards centralization. And just right now in the United States, PCR-based tests for Hop Latent Viroid are $25 to $75 a sample. So, but having explained the way that we think you have to test for this, that presents some challenges when you're trying to use PCR. So like the context of what you're testing really should determine the type of your test. PCR isn't good for everything. So, you need large-scale, regular testing, quick turnaround times. So this, I think, puts forward some imperatives. You want it to be distributed. You don't want these bottlenecks of like labs receiving samples, sitting on them for weeks. You want, hopefully, to be done at the nursery, on the nursery level, so you can get the answer right away. You want it to be affordable, simple, easy to administer. And you want it to be integrated into everything else happening, right? You don't want to have to test and then produce, just kind of make it all come together. So there's an alternative molecular reaction to PCR, which was invented about 20 years ago by the Aiken Corporation, which is a Japanese company. And it really kind of had this high point during the pandemic, because the pandemic kind of necessitated the same things that I'm talking about in the nursery, right? You need quick turnaround time, large scale. So during the pandemic, LAMP really became very popular, and there was a lot of development done into it. So different than PCR, it's one temperature, isothermal, right? So the instrumentation is much simpler. It's field friendly. You can do it wherever, If I had more than 15 minutes, I could have done one while I'm speaking. Sometimes I do that so people can see how easy it is. The sensitivity and specificity is comparable to PCR. It depends on how good you are at making these assays, but if you're good at it, then it is. 1 hour from sampling to result, and it's much more efficient than PCR reactions, so it creates a lot of products, which means that you can just like see the results, the binary result, instead of needing machines that detect low levels of fluorescence and this kind of thing. So, this is how we did it. We had this problem too, just like everybody else. And we figured out, we designed our LAMP assay, we validated it, we compared it with other stuff on the market, we made sure it worked well, all of that, the due diligence. And then what we did is, we had a plan where, we really integrated it into our our clone production system. So when we make a cut, before it goes into rock wool, we also make a second cut and we take a sample. So the sampling for the testing is part of the production for a new mother plant. And we do it 5 times at least, depends on how many cuts we're taking from a plant. We don't pool samples, we test each sample individually. So effectively, we're testing the same mother plant 5 times from 5 different parts of the plant. Sometimes one branch will come out positive, but we kill them all, we kill the mother. Because we can do it quickly in the nursery, immediately, we can deal with it. Those cuts get thrown out, the mother plant gets thrown out, and then we also do these maintenance testing because there's still some questions that are unanswered, and we're trying to answer those and share it with everybody else. Like, does it spread through runoff, right? Other viroids do. Pollen, seeds, insects. So we just try to be really careful, and we look at our tables as subpopulations. We test the tables, we sample the tables, and we make sure we're tracking which cultivars are more susceptible. There's definitely genotype effects. Some of them are more susceptible than others. And then we were able to, in a span of a few months, just knock it down to 0%. Sometimes in some of them, we catch 1 or 2. So because of that, we decided to offer this to other people. We're making a little bit of a profit off of it, but our intentions in this are really not commercial. That's not the goal of our company. We recognize that, it's kind of all of our problem because it spreads really quickly. So we really want to help people to do something about it. So we have this test that we train other nurseries and how to implement them, other labs if they want to offer it as a service. We consult on best practices that they can do to keep the nursery clean. And so, yeah, this image is actually what it looks like, right? So, I'm a scientist, I need to have some data. The top 5 are, healthy plants that were grown from seed, and then the ones where you see they're all lit up, those are symptomatic infected plants. And then we also have quantified our limit of detection with T7 promoter synthetic version of the viroid to find it's around 375 copies per microliter. So we think that's pretty good for what we're dealing with. Just want to give a shout out to 2 of my collaborators in Oakland. Chell does a lot of the work in the lab, and Melanie kind of makes sure that people can use this test effectively. I'll leave some flyers outside if people want to get in touch with Melanie about using this in wherever they want to. Give us a call. Thank you.